Crushed fruit, CF, sugar, and pectin are raw materials used in producing jam. Pectin is a white or light brown powder which is commonly used in food as a gelling agent or stabilizer, particularly in jam and jellies. In producing jam, crushed fruit containing 40 weight percent soluble solids and 86 weight percent water is mixed in a mixer with sugar 1.22 kg sugar per 1 kg crushed fruit and pectin 0.0025 kg pectin per 1 kg crushed fruit. Both sugar and pectin are also soluble solids. The resultant mixture is then evaporated to produce a jam containing 67 weight percent soluble solids. Construct the flow diagram of the process above completely. During construction, students must name the unit processes involved and use the given nomenclature stated in this question. Thus, from these sentences, in producing jam, crushed fruit containing 14 weight percent soluble solids and 86% water is mixed in a mixer. We can know that the first process is a mixer containing a crushed fruit feed of 14 weight percent of soluble solids and 86% of water. Next it is mixed with sugar 1.22 kg per 1 kg crushed fruit and pectin 0.0025 kg pectin per 1 kg crushed fruit. We can know that it's 1.22 kg sugar and 0.0025 pectin. Both are soluble solids as stated here. Thus, from the sentences, we can also know that the crushed fruit feed is 1 kg. Next, the resultant mixture from the mixer is named as M1 kg, X kg of soluble solids per kg, and 1 minus X kg of water per kg. From these sentences, the resultant mixture is then evaporated to produce a jam containing 67 weight percent soluble solids. We can know that the next process is an evaporator, with having the output of 2, which are of M2 kg jam, which is 67 soluble solids and the rest is water, and another output is M3 kg of water. The first boundary we can calculate it as the overall boundary. Boundary B is the boundary along the mixer, and boundary C is the boundary along the evaporator. The basis is 1 kg of crushed fruit feed, and the legend is as stated, where CF equal to crushed fruit, SS equal to soluble solids, and W equal to water.
Question number 2. Perform the degree of freedom analysis and then predict the first step or boundary that will be used in solving the unknown variables of your mass balance calculation. In this question, we have 3 boundaries which are A, B, and C. We first take the overall boundary, which is boundary A. It has 3 inputs and 2 outputs. In order to perform the degree of freedom analysis DOF, we first list the unknowns, which are M2, mass of jam produced in the system, and M3, mass of water evaporated from the system, and the material balances SS, soluble solids, and W, water. We subtract the unknowns and material balances, which is 2 minus 2, we got 0. Therefore, it can be solved. For boundary B, we have 3 inputs and 1 output. The unknowns are M1, mass of resultant mixture from mixer, and X, mass fraction of resultant mixture from mixer, while the material balances are SS and W. For DOF, subtract the unknowns and number of species, 2 minus 2, then we have 0, which means it can be solved. As for the last boundary, boundary C, it has 4 unknowns, M1, M2, M3, and X, and 2 material balances, SS and W. If we subtract the unknowns and the material balances, we got 2 as the balance, which means it cannot be solved. Therefore, in order to solve the unknown variables for this question, we can only use boundary A and B.
Question number 3. Perform the mass balance calculation to determine the mass in kg and mass fraction of resultant mixture from the mixer. In order to find the mass and mass fraction, we used boundary B. Boundary B has 2 unknowns, which are M1 and X. M1 stands for the mass of resultant mixture from the mixer, and X stands for the mass fraction of resultant mixture from the mixer. So first, in order to find the mass of the resultant mixture, we use the total balance equation. Input is equals to output. 1 kg of crushed fruit plus 1.22 kg of soluble solid in the form of sugar plus 0.0025 kg of soluble solid in the form of pectin is equals to the mass of the resultant mixture from the mixer. Therefore, after calculation, M1 is equals to 2.223 kg of resultant mixture. Next, to find the mass fraction of the soluble solid, we use the soluble solid balance. Same as the previous one, input is equals to output. So the first input, the mass fraction of soluble solid is 0.14 times the total mass of crushed fruit, which is 1, plus 1.22 kg of soluble solid in the form of sugar is from the second input, plus 0.0025 kg of soluble solid in the form of pectin from the third input is equals to the mass of the resultant mixture M1 times X, which is the unknown for the mass fraction of soluble solid in the output. Therefore, after calculation, we will obtain the value of X to be equals to 0.6129 kg soluble solid per kg. And last but not least, to find the value of the other mass fraction, in this case, mass fraction of water, we need to use the equation 1 minus X. So 1 minus 0.6129 will be equals to 0.3871 kg water per kg.
Perform the mass balance calculation to determine mass of water evaporated from the system and mass of jam produced in the system. To solve the question, the boundary A with its overall system is used. In boundary A, there are two unknowns which are M2 and M3. M2 is mass of jam produced, while M3 is mass of water evaporated. The law of conservation of mass is used. Therefore, the total mass input is equal to total mass output. To determine the mass of jam produced in the system, the soluble solid balance is used. Therefore, the input is equal to output. At the boundary A, there are three inputs that contain soluble solid. Therefore, 0.14 multiplied with 1 plus 1.22 and plus 0.0025 equal to output. The output is 0.67 multiplied with M2. Therefore, we can get M2 equal to 2.034 kg jam produced. To get the mass of water evaporated from the system, the water balance is used. Therefore, input equal to output. At the boundary A, there are one input that contains water. Therefore, 0.87 multiplied with 1 equal to output. The output are 0.33 multiplied with M2 plus M3. By substituting the M2, we can get M3 equal to 0.1888 kg water evaporated. Thank you.